Example, find all possible C in the closed interval from 0 to 4 that satisfies the conclusion of the MVT. That's the mean value theorem for f of x equals x times the square root of the quantity 2x plus 1. The conclusion of the mean value theorem states that there is at least one C in the closed interval from A to B for which f prime of C, that's the instantaneous rate of change at C, is equal to the slope formula f of B minus f of A divided by B minus A. Let's find our f of B minus f of A divided by B minus A. I'll begin with f of 4. That would be 4 times the square root of 2 times 4 plus 1. That's 4 times the square root of 8 plus 1, which is 4 times the square root of 9, and 4 times 3 is 12. Let's find f of 0. That's 0 times the square root of 2 times 0 plus 1, which is 0. So, f of 4 minus f of 0 divided by 4 minus 0 is equal to 12 minus 0 divided by 4 minus 0, and 12/4 is 3. That is the average rate of change from 0 to 4 for this function. Again, average rate of change. Now we're going to use the product rule to find the derivative f prime of x. Let's recall that f of x is, and I'll write this as x times the quantity 2x plus 1 to the 1/2. Using the product rule, f prime of x is going to be the derivative of the first times the second plus first times the derivative of the second. The first function is x, its derivative is 1. The second function, we just copy it. That'll be 2x plus 1 to the 1/2. Now, the second part, the derivative of the second is what we're after, so we just write the first function, which is x. Then you're going to use the chain rule to find the derivative of 2x plus 1 to the 1/2. And using the chain rule, we bring the power down, becomes 1/2, it makes it the coefficient, times 2x plus 1, and then the 1/2 that's already in the power minus 1 will be negative 1/2, and the derivative of the inside function is 2. We'll simplify this sum. So we've got f prime of x is equal to 2x plus 1 to the 1/2, and then on the right side, the 1/2 and the 2 cancel, so you'll have x, and then we will move the 2x plus 1 raised to the negative 1/2 to the denominator, so we can express that as 2x plus 1 to the positive 1/2. In order to add or subtract two fractions together, you have to have a common denominator. So let's get one for the first term, and the way to do that would be to multiply the top by 2x plus 1 to the 1/2, and the bottom by 2x plus 1 to the 1/2. Let's multiply across. For the numerator, 2x plus 1 to the 1/2 times 2x plus 1 to the 1/2, you add the powers together, that makes it 1. 1/2 plus 1/2 is 1. So you will have just plain old 2x plus 1 divided by 2x plus 1 to the 1/2. And now we can add that to the second term, which is x, divided by 2x plus 1 to the 1/2. Your numerator is 2x plus 1 plus x divided by the common denominator of 2x plus 1 to the 1/2. And finally, that derivative f prime of x will be adding the 2x and the x together, 3x plus 1 divided by 2x plus 1 to the power of 1/2. Now we're going to set f prime of c equal to the average rate of change value and then solve for c. We obtained the derivative previously, so now we're going to replace the x with c. So you'll have 3c plus 1 divided by 2c plus 1 to the 1/2 is equal to the average rate of change value, which is 3. Now, we'll algebraically solve for c. 3c plus 1 is equal to 3 times 2c plus 1 to the power of 1/2. Now square both sides. I encourage you to include this next step even if you don't need it. That is, go ahead and write 3c plus 1 squared is equal to the expression on the right hand squared, which would be 3, times 2c plus 1 to the 1/2. On the left hand side, you're going to have 2c plus 1 times 2c plus 1. So that'll be 9c squared plus 6c plus 1. On the right hand side, 3 squared is 9, and 2c plus 1 to the power of 1/2 squared, 1/2 times 2, will just be 2c plus 1. Continuing, you got 9c squared plus 6c plus 1 is equal to, distributing the 9 to both terms on the right-hand side, you got 18c plus 9. Now we'll solve this or set this equal to 0, and we get the quadratic equation 9c squared minus 12c minus 8 equals 0. We haven't quite solved for c yet, but we will. To do so, we're going to use the quadratic formula, which states that for ax squared plus bx plus c equals 0, you can solve for x by setting it equal to negative b plus or minus the square root of the quantity b squared minus 4ac, and all of that divided by 2a. Using our quadratic equation, we'll have c is equal to, the b was negative 12, so the negative of negative would make it plus or minus the square root of b squared. And so that would be 12 squared minus 4, a is 9, c is negative 8, and all of this is divided by 2 times a, which is 9. Let's do the arithmetic carefully. This is equal to 12 plus or minus the square root of 12 squared is 144. The product of 4, 9, and 8 is 288. You have a minus negative, which gives you positive, and all of this is divided by 18. Simplify it, and you get that c is equal to 2 plus or minus 2 times the square root of 3 divided by 3. That's actually two different numbers, okay? That is, when solved for c, c equals to plus 2 times the square root of 3 divided by 3, and 2 minus 2 times the square root of 3 divided by 3. Flip a few pages back or look to the top of the problem, and we found that we want to see somewhere between 0 and 4. The 2 minus 2 times the square root of 3 is negative, and so the C that we want is the 2 plus 2 times the square root of 3 divided by 3.